Good day, good day, good day. Welcome back to our YouTube channel. If you're new here, welcome. My name is Stifler. So today, I just want to focus on grade 11 and grade 12 trigonometry 2D, 3D. So this is a topic that we focus on triangles that are not right-angled triangles. How to find the sides, how to find the angles, and also how to find the area of triangles that are not right-angled or triangles that don't have the perpendicular height. So before we begin, let me just remind you of everything that we used to do from the previous grades. So in a right-angled triangle, if you're trying to find it's either the sides or the angles, we're using the ratios. So I'll just write the ratios that are most important, or the three ratios that we focus on mostly on trigonometry. So we have, if we're having a right angle triangle, we could find the unknown using sine of theta being equal to opposite over hypotenuse, or we could use cos of theta being equals to adjacent over hypotenuse, or lastly tan of theta being equivalent to opposite over adjacent. So this depends on which sides we are having. So this is our hypotenuse. So if our angle is there, this will be our opposite and this will be our adjacent, like that. So these are the ratios that we used to use if we are trying to find the angle, or if you're trying to find the unknown side, just like that. And also let me remind you how to find the area of a triangle, mostly if you're having the perpendicular height. So what is the perpendicular height? So the perpendicular height is a line that is drawn from the apex, or from the point of the third point or the third angle to the line joining the other two angles that is perpendicular to it. Just like here, you can see that this is perpendicular to this line. So it means that this is our perpendicular height. So in this case of this other triangle, we can see that from this apex to this, if we try to construct a line inside, we cannot have a perpendicular height. So our perpendicular height will be outside of the triangle. But either way, we can find the area of these triangles using the area being equivalent to half the base multiplied by the perpendicular height. So this is the area that we use to find the area of any given triangle if we are having, or if we know, the perpendicular height. So the perpendicular height is very important if you're trying to find the area of the triangle. So now we are just going to deal with different situations when we are trying to find it's either the area or the sides or the angles, whilst we are not having a right angle triangle, neither having the perpendicular height. Right. So in this first session, we are just going to focus on the area rule, how to find the area of a triangle if you're not having no perpendicular height. So how do you find the area without the perpendicular height? This is the first lesson that we're going to deal with. And then the second thing, we are going to deal with what you call the sine rule. So we're just going to find the unknown while we are not having a right angled triangle, and also the cosine rule later on. Right. But before embarking on this journey, there are situations, or there are things that you need to master about these triangles that we're going to deal with. So we can see that we're having this triangle A, B, C with angles A, angles B, and also angle C. So this angle A, it is opposite to the side BC. So in terms of the proofs that we're going to deal with, we are going to name this side BC that is opposite to angle A. We are going to name that side small letter A. And also this side AC, it is opposite to this angle B, so we can call it small letter B. And lastly, this side AB, it is opposite to angle C, so we can call that a small letter C. So the question is, how do we find the area if we don't know the perpendicular height? How can we do that? So we are going to introduce what you call the area rule. So let's just see how to prove the area rule and how to work with the area rule. So the area rule itself states that the area of any given triangle is equal to half of the product of two non-adjacent sides and sine of the angle formed by the sides. You can read that again. The area of any given triangle is equal to half of the product of two non-adjacent sides and sine of the angle formed by the sides. Right. So let's see, what does that mean? So this is just simple. It means that the area of this triangle, maybe we are knowing side C and side B there. If we know these sides, then it means that we can find the area of this triangle while we're having this angle. So just by knowing these two adjacent sides and the angle that is formed by those two adjacent sides, we can find the area of this triangle. But how? So this is the proof of trying to prove that. So in this case, since we said maybe we are knowing C and B and this angle A, so it means that we are trying to prove, or we are required to prove that the area of triangle ABC is equivalent to half. So we said half the product of these sides, so this is half of B multiplied by C, and then sine of the angle that is formed there, so sine of A. So this is what we are trying to prove in this section. So let's see how we can prove that. So before we prove, we have to construct. So what can you construct? So let's start by constructing a perpendicular height. So we can start by trying to construct the perpendicular height from the angle B to the side B, but it must be perpendicular. So we are constructing a perpendicular line from angle B to line B, like that. So now let's focus on the proof now. So in this situation, we know that, so let's call this height maybe small letter h, like that. We know that the area of this triangle can be given by using area is equals to half of the base times the perpendicular height. So this area is surely equivalent to half our base here, it is line B. So this is half B times height. But since we don't know what is our height, or since we don't know the length of this height, so let's try to find the height using what we know already. So if we check in this triangle A, B, this small or this half triangle up to this point, we can see that if we know this angle is our angle theta, we know that since this is 90 degrees here as well, we know that sine of theta is equivalent to, so what is our sine of theta? It is opposite over the hypotenuse, right? So this will be equivalent to h over c, right? But we are trying to find h since we don't know what is our height, right? And we are given this c. So if we multiply both sides by c, we can see that now our c multiplied by sine of theta, or theta it is angle A. So we can just say angle A will be equivalent to h. So it means that our h is equivalent to c multiplied by sine of angle A. So now let's replace this h on this value here of h. So this means that our area will be equivalent to half the side B multiplied by the side C multiplied by sine of angle A. Just like that. As simple as that. So now we have proved that if we are having a triangle and you don't have the perpendicular height, to find the area, we can find the area using half multiplied by the two sides that are known and the angle that is included between those two lines. You can see that. So it means that also, if we are having the same situation, we can also say that, or we can also conclude that. We can also conclude that if we are just having line A and we're having line B and the angle C there, we can also say that the area of this triangle will be the same as half of line A multiplied by line B multiplied by sine of angle C. And also the same thing if we are having the angle B there, if we are given angle B and we know side A and we know side C, we can also say that the area of this triangle can also be given by half of line A multiplied by line B, multiplied by line C, that small letter c, and then sine of angle B. So let's go back to the statement. So let's reread the statement. The area of any given triangle is equal to half of the product of two known adjacent sides and the sine of the angle formed by the sides. So we can see that it is true that the area of any given triangle, if you're having the sides that are known, two adjacent sides that are known, and the angle that they form, we can find the area since it is half the product of two known adjacent sides and the angle that they make. Now let's try to use the area rule to find the area of the given triangles. So let's see how we can do that. So here we're having triangle A, B, C, which we are knowing the line AB. We're also knowing the line AC. So this is 10 centimeters and this is 13 centimeters. And we also know the angle that is formed by those two known sides. So can we find the area? So let's see. So if you want to try this, you can pause the video and try it and resume after you have tried it. So what is our area? We know that the area is equivalent to half of the known sides. So the product of the known sides, and here we know the side AB, and we also know the side AC, and then you multiply it by the sine of the included angle, which is angle A. So this will be half of 10 multiplied by 13 multiplied by sine of 23. So this will give us 65 multiplied by sine of 23. And this will give us our area being equivalent to 25.40 centimeter squared. Just like that. As simple as that. So let's move to another example. Let's see how we can solve this one. So here we're having another triangle DEF. So can you find the area of this? Let's see. So we know that the area will be given by two known sides. So which side do we know? We know side DE, and we also know side DF. So this will be half of DE. Sorry about that. So we start by saying half. So this is half of DE multiplied by DF multiplied by the included angle, or the angle that is formed by those two lines. So this line and this line, they are forming angle 60 there. So multiply by sine of angle D. So this will be half of our DE, which is 5, and our DF, which is 7, and then our sine of 60. So this will be half of 35, and sine of 60 gives us root of 3 over 2, and we can multiply out and we can get our 15.16. So since now we don't have any units, so we just say units squared. That would be our area on this. I really hope you gained something on this session. If you have gained or if you have enjoyed, please show that by liking and subscribing. And also don't forget to comment what you think we can do better on the next session. If you have any questions regarding this, you can log into our Google Drive in this description of this video. Have a lovely day and join me when you're doing the sine rule. Have a lovely day.